electrical circuit, something you have covered in school also. First point, what causes current in electric circuit? Cause, you have a wire, what you need is a voltage which is termed as EMF, say 10 volt. This is something which causes flow of a current, charge flowing per second. But it's equivalent in a magnet. So in a magnet, say it is iron block, soft iron block or stampings. On this you have a winding. Certain number of turns and some current flowing. Number of turns N and current flowing I. If you increase the number of turns, the magnetic flux, magnetic lines you call this, magnetic flux phi m increases. If there is no current, there is no magnetic flux. If there is more current, more magnetic flux. More number of turns, more magnetic flux. That means Ni decides this flux. It is termed as magnetomotive force. In a wire, in an electrical circuit, what causes flow of current is EMF, electromotive force. Here what causes flow of flux, you say, is MMF. What is established? Point number 2. In the circuit, what flows or established is a current. Equivalent of current is magnetic flux phi m, magnetic lines. Time with you is 2 minutes, 3 minutes, 3 minutes to write. So in electrical it is a wire, you apply a voltage, EMF, what flows is current. Here you take a soft iron material. You might have seen in a transformer, in a stabilizer, the core that is termed as core. Iron stamping that is termed as steel stamping that is termed as core. On the core you have a winding. Why? Why not wood? Wood is not good conductor for magnetic flux. Soft iron is a good conductor for magnetic flux. How good? वो discussion करेंगे. Point number 3. Resistance. In electrical circuit you have resistance. In magnetic circuit the term used is reluctance. One is resistance, the other is reluctance. What was resistance? Resistivity, length by area. It is also written as 1 by conductivity. Reciprocal of resistivity is conductivity. Copper, material property, conductivity is high. Plastic, wood, paper, conductivity is low. So those materials having high conductivity are termed as conductors, and low conductivity are termed as insulators. In the reluctance also, reluctance, the symbol is Re. This is how you write. It is not R. This symbol is combination of R and E, but you write is R. Re, symbol is like this, is equal to L over permeability, nu A. So if length is more, resistance is more. Here also, if this length is more, opposition is more. If cross-sectional area is more, resistance is less. Here also, if it cross-section is more, opposition will be less. So resistance depicts opposition in electrical circuit, reluctance gives you opposition in magnetic circuits. Then what is this? If conductivity is high, material is a good conductor for flow of current. If a permeability is high, material is good for magnetic flux, and it is written as mu naught into nu r into A. What is nu r? Relative permittivity. Nu naught is permeability. Correction is required. Relative permeability. Nu naught is permeability of a free space. So if you make electromagnet of free air, only air, like this, if you take a winding like this, what is the material inside? Air. So for this value, nu r is equal to 1. For soft iron, nu r is 1000. That is why whenever you make electromagnet, you make use of a iron ore, because it will increase its magnetic flux carrying abilities by 1000 times. Opposition offered will reduce to 1 by 1000. So for iron, nu r is equal to what? Approximately 1000 for soft iron. That means whenever you make a transformer, stabilizer, any material, motor, generator, wherever you need magnetic flux, you will make use of what? new R, high new R. It is normal iron 1000. Japanese core is available for which the new R is of the order of 4000 also. Expensive material. For that material, advantage is it is easy to make a magnet or current required will decrease. That is why a 5-star air conditioner will use what? High value of a new R. So current required to run it will be less. So that is why it is expensive. For new R, high new R materials are expensive. Capital investment is more, but running expenses will be less. Regular of the bill cut aayega. Initial investment will be more. Time with you is 2 minutes. Pen down point number 3. Point number 3. Fourth point is, yes, electric field intensity E. If the voltage applied is V naught, length of the conductor is L, then electric field intensity E is equal to voltage per unit length. Say voltage is 10 volt, length is 10 meter, 10 volt by 10 meter as an example. 10 volt by 10 meter is 1 volt per, yes, its equivalent in magnetic circuit is magnetizing field intensity H. मैग्नेटिक फ्लक्स डेंसिटी कोई हो रहा है, B is different, उसकी गल बाद च करांगे. H, it was EMF per unit length. E was EMF per unit length. This is how E was defined. H is what? MMF per unit length. MMF is how much? Magnetomotive force, Ni by L. What is L here? L is this length. This total blue color path length is L. Time with you is 1 minute. Point number 4. Point number 5, yes. Point number 5 is what? Current density. Its equivalent for magnetic circuits is what? Point number 5, current density. J, symbol is J, is equal to current carried I by cross sectional area of the wire A. It is I by current flowing per unit area. For air conditioner, why the wire is thick? Current required is more. That is why you need more area to carry that current. Suppose for copper it is 10 ampere per square mm. Suppose. So if you need 10 ampere, you need 1 square mm. Fine. If you need 20 ampere, you need double the area. If you need 30 ampere, triple time. If you need 40 ampere, 4 times. So if you need more current, you will have to use thick wires. J is magnetizing or magnetic flux density. That's the right term is magnetic flux density. Symbol is B, is equal to flux. This is a flux divided by cross sectional area A, magnetic flux phi m over area A. 1 minute to note. 1 minute to note point number 5. Magnetic flux by area. MMF is equal to NI. Point number 6. That is what the purpose is. Why we have taken up this article is point number 6. 3 marks board question. Find a relationship between B and H. B is a magnetic flux density. So you want to find a B, how it is related to H. Ohm's law. I is equal to what? Voltage by resistance, EMF by resistance. Equivalent of I, yes, magnetic flux. Equivalent of EMF by reluctance. MMF is equal to what? NI. Reluctance is equal to what? L over permeability into A is equal to NI by L. Nu you can shift in the numerator, A you can shift to the numerator, phi m magnetic flux per unit area is equal to nu times Ni by L. Yes. Flux per unit area, magnetic flux density, B, nu times Ni by L is what? H. So relationship between B and H is what? B is equal to nu times H. Now the use. If you have 10 turns, likhna nahi at present, 10 turns, 1 ampere current. MMF is 10. Two options. Option number 1, use wood. For wood, nu R is say 1. So you get small value of B. Second option, use iron. Iron is a good material for magnetic flux. If you use iron, nu R will be how many times? 1000 times. So with the same current, you can produce 1000 times magnetic flux. That is why iron, you will use soft iron for making this. One. Now commercial part of the same. Suppose you want to design a compressor for air conditioner. Engineer number 1 suggests use wood. So you will have to develop the same flux. For the same flux, you will have to flow 1000 times. Current flowing will be how many times? 1000 times. So for iron, if your electricity bill is 1000 per month, for wood, it will be 1000 times. 1000 into 1000 is 10 lakhs. Difference पता लग गया? रीजन हुण पता लग गया क्यों जाते IIT, क्यों जाते एम्स? कि अगर इन्हें जो डिजाइन किया, if there is a 1% change in cost, 1% change in cost will justify his salary of crores of rupees in a day. Annual salary crores ही है ना IIT वाले ने. एक दिन दी उहदी मेहनत करोड़ों रुपए का एडवांटेज कर सकती है. That is the reason. So back, nu R is high for soft iron. So by using this, current will decrease. My electricity bill will also come down. Time with you is 3 minutes. 3 minutes to write. Yes, question number 7. Please refer to question number 7. Amperes Circuit Law. State and explain Amperes Circuit Law. it is a repetition of what you have done. There is a wire. Surrounding a wire, if there is a current carried, there is a magnetic flux surrounding a wire. So, you have a wire which carries current I, and surrounding this wire you have a magnetic flux. Why this? Same wire, place your thumb parallel to the same. Karo. Yes, here it is into. To the left it is towards the reader. So, magnetic flux surrounding a wire is given. The law is total MMF. But before we take up total MMF, can we try MMF in this small part? Only this part. H represents what? MMF per unit length. Agreed? Say 10 units per centimeter, and suppose it is 1 centimeter. So, MMF is how much? 10 units. So, HDL represents what? Small MMF in part PQ. Say this part is PQ. Total, this represents total MMF. But if you start from a point, end up at the same, you complete a loop. If you start from here, complete the loop, reach back to the same position P, then we write this total MMF in a closed loop. If this is a length, this is closed, it means closed loop. If it is area, chapter 1, Gauss's law, it is closed, then it means what? Closed surface area. Yes, Nariyal, okay, sphere, football. Here it is length. Close means closed loop. So it represents what? Total MMF in closed loop. The law is total MMF in a closed loop is equal to total current contained. Total current contained in this case is what? I, 10 ampere. Take another wire, same direction, now it is 20 amperes. Take one more wire, now 30 amperes. If n wires are there, n times 1, 2. If a wire 1 carrying 10 ampere upward, another wire carrying 10 downwards, then total MMF contained is 0, because this will give you what? Flux in this direction, the other will give you in opposite direction. These two will create magnetic flux, those will cancel each other. So, the result is 0. What the law is? Amperes Circuit Law. Total MMF in a closed loop is equal to total current contained. Time with you is 3 minutes. Question number 8. Yes. You have to use Ampere Circuit Law. For what purpose? To find magnetic field surrounding an infinite wire. Use Ampere Circuit Law to find B or H due to infinite wire. Result check करो पहले, same है, something which you have covered, same result है. That means Ampere Circuit Law is another method to find magnetic field due to infinite wire. Again, what you have covered is a wire. This is how we started. A wire infinite long. So you have to find out what? If it carries current, find magnetic field at any point P at certain distance from the wire. What was the answer? B is equal to nu naught I by 2 pi r. So a wire, you have to plot a graph. It carries current I. Below this you will plot a graph. How H varies with R, how B varies with R outside the conductor. So at any point P at a distance R, there is a magnetic field flux. Use कड़ा करना है, law कड़ा use करना है, बोलो. You have to use Ampere Circuit Law. As per Ampere Circuit Law, total MMF in a closed loop is equal to total current contained. In this blue color loop, what is the total current contained? I. So, as it is, this is only the magnitude analysis, the direction we know. H remains the same or different? At distance R, 1 meter, 1 meter, 1 meter, 1 meter, all these points are at a same distance R. That is why value of H remains same. What does it mean? DL. DL is small length. Total length of a closed loop. Total length of closed loop. In this case, this loop is a circle. Total length comes out to what? 2 pi r is equal to what? So H is equal to what? I by 2 pi r. This is first part, how to find H. Second part, how to find B. It is with an assumption that there is air surrounding this wire. Like in this case, what is in the surrounding material? Air. For that you can take nu r equal to 1. So B is equal to nu times H is equal to nu naught into nu r, which is 1 into H, is equal to nu naught into H is equal to what? I by 2 pi r. So B is equal to what? Nu naught I by 2 pi r. H, yes, as R increases, H decreases. Anything, effect, as you move away, the effect decreases. So it is inversely proportional to R. B also, B is equal to nu naught I by 2 pi r. As R increases, B decreases. Time with you is 3 minutes. 3 minutes. Numerical number 12. The question is a long, straight, solid metal wire of what radius? R. So now it is a thick wire. It carries how much current? Yes, I. Current flowing is I. What you have to find out is magnetic field. Where? What is the radius of the wire? Capital R. What you have to find out is B. Inside and outside. Why I will answer it in the form of a graph? Because number of times in competition. You had this question number of times in competition. In form of a graph. How B varies inside and outside a wire. First part, outside. Because it is simple. Case 1, outside. You have just covered outside the wire. Say any point P. At what distance from the center? R. Apply Amperes Circuit Law. Total MMF in a closed loop is equal to total current contained. What is the current contained in the loop? Yes, in this loop, total current is I. The whole current is inside the blue loop. So you can take H constant outside, dl is equal to I, H into dl integration. Total 2 pi r is equal to I, H is equal to I by 2 pi r. Same derivation, no change. Nu times H is equal to nu times I by 2 pi r. How B varies outside? Yes, outside inversely proportional to R. This is the answer in objective question. Complete it, 1 minute to complete. Same derivation, no change. Outside the wire, let me assume it is air. Same as previous. Case number 2 is inside. When you say inside, you will have to find somewhere here at a distance r. Inside, again, you will have to think of a loop. If you think of this loop, then you will have to find out current flowing in this part. Is it less than I or equal to I? Less than I. Concept is same. No change. Inside means R varies between 0 to R. No doubt at the end we write equal to also, and we see whether it is equal to R or not. I is not capital I now. I up to R. Left hand side treatment will be same. Anyone? How much is the current flowing here? Yes? Per unit area, correct? Concept is excellent. Total current is I. Total area, this is capital R, this radius is capital R. So this total area is how much? Pi R square. You get current flowing per unit area into this area. Pi small r square. Left side is the same, no change. 2 minutes to try. No change on left side treatment. 2 minutes का टाइम इतना भाई हो गई अटेंडेंस H you can take it out. DL H. DL is 2 pi R is equal to I. Pi cancel. R square by capital R square. Solve करके H की आया. This is R power 1. This is R power 2. I over 2 pi R square into R. How H varies as a function of R? Directly proportional. So this is a separate objective question. Inside HR graph will also be a straight line. B is equal to nu naught into nu R into H. H is how much? I R by 2 pi R square. So it is also a B is proportional to R. It is also a straight line. When R is 0, B is also 0. Question is whether it will meet at this point or not. IIT I have a question. It will depend on value of nu R. If nu R is equal to 1, if you assume this material is also having same nu R, then and only then the two will get the same value. If nu R is more than 1, this point will be above this. If nu R is less than 1, we'll discuss, then this point will be below this. IIT level 3 I have a question. Objective. किन्नो ग्राफ बने ऐसी ये दसना सी किस केस this graph will be up to this point, at this point or below this point. That means issue is what? Nu R. This material, wire, surrounding is air. This wire is made up of what material? Nu R value is what will decide. If nu R is equal to 1, let me assume nu R is equal to 1, then it is this.